Good morning, dear students. As in the previous lecture, we have started binomial theorem, and this is the second lecture I'm going to take. In the first lecture, I've explained you the basics about binomial theorem, and we have seen one expansion where we have taken a binomial expression with nth power, and n being a natural number, and we have expanded. I've showed you some examples also, and also I told you to read the some important observations, special cases, and remarks. Okay, I hope you have done, because those things will be helpful in solving the exercise questions. Okay, and we have started the exercise also. I told you to do some questions. Some of you have done. That's good. Okay, now we are going to see some more questions of the same exercise. Okay, some challenging questions of the exercise. Okay, so let us see. But before doing question, let us see this expansion. I have not taught you this expansion, where if you have a minus b the whole power n case. Okay, so first of all, how we can express this a minus b the whole power n? Can we write this expansion as a plus minus of b whole power n, where a will be the a, but in place of b we'll write minus of b. Okay, so that is how I've written mine. In place of b, that is minus of b here, minus of b square, minus of b cube, and minus of b the whole power n. Now as you can see that this in turn can be written as this: nc0 a to the power n, this minus here plus this positive will become negative, so minus of nc1 a to the power n minus 1 into b, plus this will remain same. Okay, and this will become minus, and will go up to n, where ncn minus b to the power n can be written as minus 1 to the power n. How this? See, minus of b to the power n minus of 1 into b whole power n, we can write this as this, and the n will be distributed according to the law of indices. So minus 1 to the power n, ncn b to the power n. So what you have to remember, the only thing, in the positive case we put positive in before all the expressions, but in the negative case we have to put positive and negative. That means in the alternate conventions, that is positive negative positive negative positive negative, and up to end. So if you could remember this, you can easily expand a minus b the whole power n. Okay, as I told you to do first 5 questions, that is 1 to 4 questions. In this, you only have to find the number of terms in the expansion, which you can easily do. In the fifth question, as you can see that I'm doing third one, that is 2x upon 3 minus 3 upon 2x whole raised to 4. Okay, so this is the case of a minus b the whole power n. Okay, so let's expand this one. The power is 4, so how many number of term we will get after the expansion? That is 5. Okay, because we always get one more than the index of the particular expression. Okay, so nc0 a to the power, what is a, 2x by 3 whole power 4, then minus y, because we have to go alternatively, because this is a negative case, so positive negative, then nc1. Okay, in place of n we can write 4. Okay, so I've written 4. Then what is a? That is 2x by 3 whole power 3 into 3 by 2x whole power 1. Now don't take minus of 3x by 3 by 2x, because we already did minus here. Okay, one more thing I'll tell you, just let me just write this expansion: 4c2 2x by 3 whole power 2 and 3 by 2x whole square, and minus 4c3 2x by 3 whole power 1 3 by 2x whole cube, and positive 4c4 3 by 2x the whole power 4. This power will be 0, and that is 1, so that I have not mentioned here. Okay, so you got 1 2 3 4 5 terms. One thing. Second thing, how to confirm that your in between your solution is correct? So always see the power. See, the total power is 4. Here the total power is 4. Here also in this expression the total power is 4. Here also 4 and here also 4. Okay, that is how you can have a check that whether your steps are correct or not. Now you know what to do. A simple algebraic solutions, 4c0, 4c1, 4c2, 4c3, 4c4. Just put all the binomial coefficients by solving it with the either calculator, or if you know the value, that's better. Okay, and this expressions, just open it, cancel it, and get the final step of the solution. Okay, similarly, as if you can see the sixth one, that is of three term, that is trinomial expansion we have to do. Okay, so for that trinomial expansion, just make it a binomial. If you have 1 plus x square the whole cube, so you consider 1 plus x as a one term and x square as the other term. Now expand it. How you'll expand? 3c0, 1 plus x to the whole power 3 plus nc1, sorry, 3c1, 1 plus x into x square the whole, this will be square and this will be the power 1. 3c2, 1 plus x and x square the whole square, the power will be 1 here, and 3c3 x square the whole cube. Now what you'll do? Now again 1 plus x the whole cube, you know. Okay, just open it and try to add any, if any term is getting added, just add it and get the final result. So like this we have to do. Now if you come to the next question, that is 96 the whole cube, 101 the whole power 4. Such type of questions we have done in the 9th class. Okay, how we have done in the 9th class, you know, see, say for example 99 to the whole power 5. So how we can do this? 100 minus 1 to the whole power 5. Similarly, 10.1 to the whole power 4. This can be done as 10 plus 0.1 to the power 4. Then 102 to the power 5. Again 100 plus 2 to the power 5. Just use the application. See, that is what will use, no, to find the values. We use binomial theorem, so that is what we are that is what the application means. Okay, so try to do this. Okay, all right, let us take this question. This question says that which number is larger, 1.1 to the power 10,000 or 1000. Okay, so let us do this question by using the binomial theorem which we have. We can write 1.1 as 1 plus 0.1 to the whole power 10,000. Now if we are expanding it, so how we will expand? Okay, don't think that we'll be expanding up to 10,000. No. Okay, just one or two starting expansions will do. That is 10,000 c0, 1 to the power 10,000 plus 10,000 c1, 1 to the power 9,999 into 0.1 to the power 1, because the total power should be 10,000, and plus other positive terms will write like this. Okay, let us not find the other terms. Let us just calculate this, because this is easy to calculate. You know, 10,000 c1 is what? 1, and 1 to the power 10,000 is 1. So finally 1. Okay, and plus 10,000 c1 will give you 10,000, right? Into 1 into 0.1 into 1 will give you 0.1. Now if you multiply this with this, you will get 1000, and which will again plus other positive terms. Okay, please keep on writing this, plus other. Now it doesn't matter what does that other terms are. We are only concerned that either this is larger or this one. So as you can see that we got, by the first two expansions, we got what? That is 1001. So from here itself it is clear that 1.1 to the power 10,000 is larger than 1000. Okay, I hope you have understood this thing. Okay, now from 9 to 13th I'm leaving it for you. Why? Because you will see a very some different kind of thing in this questions. How? See, First of all, they are asking that what will be the expansion of a plus b the whole power 4 minus a minus b the whole power 4. Now with this, they're asking that if you could get the answer of this one, then try to put it in a particular way, that is root 3 plus 2 the, say for example I'm taking this question, root 3 minus 2 the whole power 4. What will be the answer of it? So first of all, you solve this general question and get the general answer of it, and go particular with this. Okay, so where a and b are root 3 and root 2, and in your answer just put the value of a and b and get the final answer. Okay, so up to 13th you can easily do. Okay, so try to do it. All right. Okay, see, this is the 15th question. How we are going to do this? You're given that prove summation of r from 0 to n 3 to the power r ncr is equal to 4 to the power n. We have to prove this thing. Okay, so you can prove by taking LHS also as well as RHS also. We will see both the cases. Okay, so from here, see here, what can we do? Taking LHS, I've just opened, or we have expanded this particular LHS where r equal to 0. So first I have put r equal to 0. So 3 to the power 0 nc0 plus 3 to the power 1 nc1 plus 3 to the power 2 nc2 plus, and so on. Okay, up to n. So 3 to the power n nc n it is going. All right, now see, as you can see, let us rewrite this in a very proper way, that means in the general formula or the general theorem which we have for the binomial, right? So first of all, nc0 we write, and then 3 to the power 0. Can I write 1 to the power n? Okay, because 1 to the power n is what? 1 only, and multiplying by this will get the same. nc1 1 to the power n minus 1 3 to the power 1 plus nc2, this nc2 into 1 to the power n minus 2 and 3 to the power 2, and so on up to ncn 3 to the power n. See why I have included this one in all the expressions, because to make this, to fit this particular step in the formula and get the answer of it. Now if you see that this is whole expansion of 1 plus 3 to the power n. Okay, if you expand it, you will get the same step here, and from here to here and here to here. So 1 plus 3 is what? 4, and that is how you got 4 to the power n is equal to this thing. Okay, just if you won't understand this, just go back and try to see from the, listen very carefully from the starting. Now how I was doing from the RHS side, see 4 to the power n. Now you have to see your proof. You have to just focus on your proof, that what actually the proof is asking. 4 to the power n is here and 3 to the power r. So this 4 to the power n, you have to use your brain and write this as 1 plus 3 to the power n. Now expand it, the second last step what we got just some minutes back. Okay, that step you have to write here, and then again the previous step, and finally you have to write this, and like this you can prove. Okay, so by RHS also you can go by this way, or by the taking LHS. Okay, now 16th question, I'm leaving it for you. By using the binomial theorem, prove that 2 to the power 3n minus 7 minus n is divisible by 49. See, such type of questions we have seen in the principle of mathematical induction, where we have taken some lambda and we have solved by that way. Okay, so now the question will be asked in such a way that by using the binomial theorem, you have to prove that this is divisible by 49. So how you will do it? See, what we can do, 2 to the power 3n. This 2 to the power 3, it can be written as 8 to the power n. Can we write like this? Because 8 is what? 2 to the power 3, and 3 into n will give you, and then minus 7 and minus 1. Now this 8 can be written as 1 plus 7 to the power n minus 7 and minus 1. Now using the binomial expression, just expand this, and whatever things are cancelling, just cancel, and finally you will get a term which will be divisible by 49, and you can easily do this question. Okay, so try to do this. Okay, we'll see the general and middle term in the next lecture. Okay, and we'll do this exercise within 1 or 2 lectures. Okay, then sequence and series will be starting, and your okay, so just do the question, see the examples. Okay, try to do examples also, because that is very important. Okay, because this is chapter is very scoring one, so please focus on this one. All right, I hope you'll do. Thank you so much. Have a nice day. Bye bye.